Hello, welcome to Lab 3 Magnetic Field of a Bar Magnet. Introduction. The purpose of this experiment is to explore the concepts of magnetic field by measuring to determine the magnetic field's dependence on distance. This will be compared to and visualized by a computational model using the Biot-Savart law. This is the Biot-Savart law noted by this equation, and it uses current and distance from source R. I don't know why it changed it to this R. But here is the equation for B dipole perpendicular. And this is a bar magnet magnitude, or the magnetic dipole, and here's another equation to compute that. Initial conditions: the system, observation point, or the magnometer. Surroundings: the bar magnet producing the magnetic field. This is treated as a magnetic dipole. This is a visual model or magnetic field lines due to the bar magnet or the magnetic dipole. Brief preview of the main result. In this experiment, as expected with the model, it was found that the natural log of the magnetic magnitude on B was related to the natural log of the position R in a negative linear fashion, noted by this equation. Procedure: the materials, bar magnet and magnometer application, meter sticks, and tape. Compensating for magnetic north. Orienting the magnometer has an x component of 0. Finding the magnometer chip and measuring the on-axis and off-axis magnetic fields. This is a brief example of the approximate setup of the experiment, as we were unable to take a photo of the experiment while it was occurring, as we were using the phone at that point to calculate the magnometer. Here is the data that we obtained and the graph of the data points of the ln of Bx versus the ln of R. Observations and calculations. Observations and calculations. As the magnometer moves further away from the magnet, it measures a lesser value, and as the magnometer moves closer to the magnet, it measures a stronger value, as expected. Here are the equations that we use to calculate using the data received, and this is the best fit line and the numbers that we were able to obtain from this best fit line. Here is a computational model that I was able to create to model the situation, to give a more accurate modeling of the expected data. Here is a preview of the computational results with the magnetic field, magnetic impulse in the field, and the result of the perpendicular and on-axis charges or fields. Possible sources of error in my experiment: the imprecision in the phone's application's accuracy, or the phone magnometer's application's accuracy. Inaccurate placement of the magnetic north. Human error in measurement, interference with potentially ferromagnetic materials, and magnetic measurement in the x and z axes. What if and what if? What if you had not oriented your experiment to compensate for the magnetic north, or did so incorrectly? In this case, the force of the magnetic north would be acting in a different direction than planned. This would cause the sum of the fields potentially distorted in the x and the y axes, and the x-axis would potentially not start at 0. And what if your stick had two identical magnets together end to end? This would increase the magnetic field, likely doubling the amount of magnetic field detection at the same distances.